So now we are going to divide both sides by minus 4. Y is going to be equal to minus half. Alright, because if I take minus half, put in here, the minus is cancelled. 4 divided by 2 give me 2. Alright, so if y is minus half, and I put that in here, 4 over 2, x is equal to 2. So we found the value for the y, and by finding this, we find the value for x. So that is why we had this in the first place. The x plus 4y equals 0. We had to make x become minus 4y, and we substitute it in what we have up here. Right? Minus 4y times 4 minus 16y. Add it to 8y, you get this. Then you combine this with that. And of course, you make this here equal to that. Because the whole point of when you deal with indices, exponent is equal to exponent, and then you just work with that. But yeah, if we understand the basics of indices and the rules, I mean, there's what? There are 6 main rules, and they're not really hard to remember, right? Like. So let me give a few examples of it, right? So you have the multiply rule. So that's a multiplying rule. The dividing rule is that, right? So it's just an inverse, right? Now there is another rule. There's the inverse rule. So the inverse rule is something like this. Let's say I had 3 to the minus 4. 3 to the minus 4 is the same as 1 divided by 3 to the 4. And that's the reason why when you're dealing with a lot of things in maths, especially with later topics like trigonometry, when you see something like sine to the minus 1, then that principle comes from indices. And even in matrices, you have finding the inverse of a matrix that you use as like a raised to the minus 1. Right? So representing it like that, it comes from that, and also what you would call scientific notation. Alright, there's another rule. So these are the first 3 rules well, I wouldn't say those are the first 3. This is another rule that's very important, that obviously that's the inverse rule for that. The other rule that's important is the distributive rule, right? Alright, we did this, so we can get rid of this, because those are the easiest ones to remember. Right? Those, not too difficult to remember. So you have something like this. So once there are brackets, you are literally, yeah, you have that. Now, mind you, there is a unspoken rule about, let's say, something like, what if you had 3a raised to the 2 So, hold on. I don't want it to just be that. 3 to the 3 times a raised to the 2. All of that raised to the 4. Now, the reason why this is important is because I don't think a lot of people pay attention to this aspect of it. So, yes, it's true that you're still going to have 3 to the 3 times 4, but also you're going to have a raised to the 2 times 4 as well. So then now, in this case, you're going to end up with 3 to the 12 and a raised to the 8. So you had this. Yeah. So the second part is an unspoken rule in indices. So meaning you're not just raising this to the 4th, you're raising everything in the bracket to the 4th as well. So everything that's on the inside of the bracket gets raised to the 4th. Believe when I tell you, a lot of times that gets overlooked. So if you're teaching this, you should also teach this. Right? That's yeah. Because that will trick you if you're not prepared for it. Now, what's the other rule that's very important? The other rule that's important is, and this one is fairly straightforward, and it goes like this. Any number that is raised to the 0 is equal to 1. It makes sense if you think about it like this. Remember the rule about this? There's a rule where you have 3 raised to the minus 1, right? And that is the same as 1 over 3 to the 1, right? But what's the joke? That is 3 to the minus 1. What about 3 to the positive 1? Well, that's the same as what? Just, you can write it the same, whether you can write it as 3 or 3 to the 1. It don't matter. Right? Whether you say 3 is equal to whatever. Yeah? You can do that. Now, there's a reason why I put these two together. Because a substitution for this, 0. 0 can be replaced by what? 1 minus 1, 2 minus 2, etc., etc., right? 5 minus 5, whatever. But let's just focus on what we have here. The 0 equal 1 minus 1. It basically means that you can replace the 0 with 1 minus 1. But if you were to separate these exponents, it would end up looking like 3 to the 1 times 3 to the minus 1. Yeah. So, this is the same as saying 3 to the 1 times 3 to the minus 1. But we know that 3 to the minus 1 is that 1 over 3 to the 1. So if we replace that with this, and then you divide this by this, then any number raised to the 0 is always equal to 1. And it don't matter what it is. So it could be 1 million raised to the 0, 350 raised to the 0. Anything that's raised to the 0, all is equal to 1. Every single time. Now there are other important indices rules. Another one. It's the ones related to what we do in changing the subject of the formula. So to put a long story short, the square root of a is same as a raised to 1 over 2. The cube root of a is the same as a raised to the 1 over 3. Now there are times when they get a little bit, you know, what's the word now? They get clever with these a lot of the time. Because sometimes they say, well, what about if I wanted you to find a to the 3 over 2 and a to the 2 over 3? What would that look like? Well, imagine it like this. What you had before was 1 over 2. Well, if you were to separate that, the a raised to the 1 over 2 has a 3 on